Hi, everyone. So thank you so much for staying the whole duration of the day. It's been a really long day. And as I said at the beginning, we're going to cover a lot of ground. And we really did, going from human AI to local AI to spatial AI to urban AI. And now we're going to, on the one hand, bring everything together and to sort of address AI in this multi-dimensional and multifaceted way. And also Kate over here is going to move us to the planetary scale. And it's a different kind of a planet than the one that we usually think of, because she's Kate. We're going to go deep into the Earth, and we're going to go high up into the atmosphere, and we're going to talk about the planet in a new way. So all this is to say that I'm so thrilled that you agreed to be our keynote, and I'm happy to be in conversation, and we'll see sort of where it goes, and we'll do it in a very open-ended way. But for those of you who don't know Kate, I think that she has been the one to introduce AI to us in just a completely different way than everybody thought about, because we're also used to thinking about AI as computation, and her work very quickly introduced us to the fact that there's labor involved in AI, that there's politics, that there's minerals, that there's all the things, extractive economies that we really need to think about when a new technology emerges. And she did this, with books and with what we're going to look at today, these system diagrams. And system diagrams are something that are very familiar to us as architects. And so we're going to look very closely at all these amazing drawings that she's done with her collaborator, Vladan Joler, that's how I pronounce it, yeah. And so, if you don't know Kate, please look up her extensive bio in our little book that we put together. But she's now a professor at the USC Annenberg, Annenberg School of Communication, right?
NSDS.
Yeah, NSDS, right? And she's also a principal researcher at the Microsoft Research Labs Center. And she's also the inaugural visiting chair for AI and justice at the École Normale Supérieure in Paris. She's written a book, Atlas of AI, which has won so many awards and taken her on so many adventures and giving talks all over the world, and also resulted in this work that you see over here on the screen. But as we were discussing this conversation that we're having, she's also going to show this other much larger version of the anatomy of AI, which she told me started during COVID, and I'm absolutely not surprised that you went from this to this during COVID, and so we'll talk about all of those transitions. So I just want to go back to the beginning of the day, because not all of you were here in the morning, to just reiterate, that our intention today was really to talk about our hopes and fears related to AI, and to look at ourselves and to see what's been happening at GSAPP, not by saying what will we do, but what we are doing. And I think we saw so many different teachers, our friends from MIT and other places who are always really in dialogue with us. And also just to talk about the different languages that we've been speaking in today. Because as academics, and probably, I don't know which words you'll use, a lot of us talked about the socio-technical problems which emerge from applications of AI. We've talked about the biases, but also creativities and infrastructures, and as we move beyond. And then there's, another world that's thinking about AI, and all the practitioners. There were many practitioners and entrepreneurs who presented today who didn't quite use the word, but there's a word, sort of moving around in the more practice-oriented world, which is called the alignment problem. So imagining. It's on the one, it is critical as well, but it's really imagining what can go wrong when technical systems are given the ability to make judgments, even with humans in the loop, and their attempt to align their values and ethics, in terms of what they expect from the designs that they're putting out in the world. And I cannot imagine, a better person than Kate to sort of start off this discussion. Okay. So I have a number of questions, then we can stray from them, because I know you're gonna talk a lot as well. But I want to start by addressing this anatomy of an AI system, and in relation to the book that you wrote, The Atlas of AI. And in it, you get us to pay attention to resources, water, the energy involved in the production of AI, which was really, and all those energy systems which weren't mentioned so much during the talks today, because we were so grappling with what it means working with these technologies. So it might be a nice moment to just sort of step back and have you just explain that, why you did that and how it started.
Well, first of all, hi everybody. It's so lovely to see you all here. Whenever Laura asks me to come and do something for GSAPP, I always say yes, because I inevitably get to hear fantastic talks and have wonderful conversations with friends and students here, and I always learn so much. So thank you for inviting me. And I was also really delighted that we could do this in conversation, because you can go and hear talks anywhere, but to have a more intimate conversation about what we're thinking, what we're working on, the problems that we're seeing and how we're addressing them, that's something we can do in one of these more intimate contexts. So I'm really delighted to be doing this with you, because you and I have been having this conversation, I feel like, for at least a good decade or so. So let's go back in time then and talk a little bit about the start of this project. So Anatomy of an AI System really came out of a set of conversations in 2016 when I was at a conference about voice-enabled AI systems for public data. And this was a really interesting concept. It was, really during the emergence of Alexa and Siri, and there was real concerns that as we move to voice-enabled AI, that we don't really have large publicly available models where you could actually do really strong voice interaction. So again, this organization was proposing, effectively having a public donation scheme for data to make one of these models to be usable. And when I met Vladan, we were sort of talking about, well, it's all very well to have the data, but why are we not talking about what it really takes to build a large-scale voice-enabled AI model, which is that you have to think about the entire life cycle. You have to go all the way back into the various minerals that are used to produce not just the individual devices, but the full computational stack. You have to look at all of the practices that get those technologies into the actual supply chains, including sort of smelting, manufacturing, container shipping. And then you need to think about the middle layer, which is really what happens in the data pipelines. How is data extracted? How does it move around? What are the environmental footprints of doing data at planetary scale? And then finally, what happens at the end of life of something like, an Alexa inside an Amazon Echo? These devices are traditionally used for about 3 to 4 years before people throw them in the bin. And of course, they end up in giant e-waste tips in places like Ghana and Pakistan. They used to go to China, but China just relatively recently said that the e-waste was just far too damaging and too toxic, and they stopped taking shipments from international e-waste. But of course, other countries that have less wealth have now been accepting those shipments and dealing with those profound and ongoing environmental consequences. So doing this work really started out as a series of giant pieces of paper, like butcher's paper, where Vladan and I would start drawing, okay, here's the data pipeline, we understand that, but let's talk about the mining processes that precede it, and then let's talk about end of life. And then before we knew it, we had dozens of pieces of butcher's paper, and we thought, okay, we've got to actually do this properly. That commenced a 2-year research project, which took us all around the world to try and get really difficult to get information that is about supply chains that are intended to be opaque. It's very, very hard to get this sort of information. And in many cases, we hit our own black boxes. I love that Sarah was talking about black boxes just earlier. It's not just the black box of technical design, it's the black box of industrial infrastructures, and it's the black box of corporate law, whereby many of these things are actually kept as some of the most closely guarded corporate secrets you can find. So we rely on things like FOIA requests, on whistleblowers, on people inside industry telling us how these things were being made. So it changed me, I would say, as somebody who'd been really studying AI for, at that point, over a decade. And it really made me realize that there is a very different story when we start to put AI in a material context. So from doing this project over 2 years, looking at a single device, which was the Amazon Echo, I decided to expand the study to look at the AI industry itself. And that took me on a 5-year journey, and that became Atlas of AI. And in doing that, it meant studying everything from labor pipelines, data pipelines, all of the environmental impacts, through to what happens when you apply these systems in government, when you use them in war, and of course, when you use them in the processes of civil society. So that's kind of the short version of this project, and I think in many ways it marks a turning point for me in terms of I stopped thinking about AI as just algorithms in the cloud, it's a set of immaterial processes, or even just about the data pipelines, but always this much larger material set of practices that in many cases people in this community know well how serious they are. It's just so rarely applied to AI. You talk to an architect about the material impact of creating a large-scale building and they'll know all about it, but you ask them about the material impacts of an LLM and they won't know. So why are we thinking about these architectures differently? And what can we learn if we ask these questions about the materiality of AI that would change how we would use them and how we would apply them?
Yeah. So maybe you can talk a little bit about these some of the FOIA requests that you had to ask for to produce something like this, because I think what's so amazing about this, just as a drawing, is the realm of activism and of action that emerged around it, right? So it wasn't like you were an activist like running around the world doing this and that, but the conversation that emerged around all of these things really had a profound influence on the way a lot of people, especially in this kind of room, think about AI. So I'm just curious how that kind of process starts. It just looks all so clean and laid out and easy, and that it's in some ways hand-drawn, but in other ways there's data visualizations, and we're going to talk about that later when we go to the much bigger drawing. But just one story that was really difficult, and that you had to FOIA something to even get from one place to the next in your research.
Well, there are several in this map. And there's a lot of difficulty at various points. And interestingly, when I think about this project, it's not just a map, of course. It's also, if you scroll below, it's also an essay. So you can read this to see, I think, in some ways, where those stories came from and those experiences and how we got there. But I also want to say that in the case of doing FOIAs, this was very much, the benefit of being in community with others. So amazing legal scholars like Jason Schultz really helped us do things like find out and do FOIAs specifically around the supply chain for large-scale computation. It was interesting, actually, through one of the FOIAs that we pursued with a major technology company that was doing public contracts. Of course, it's in public contracts where you can do these freedom of information requests. That actually inspired that company to do their own forensic research into their supply chain, which took them 3 years in order to figure out if there are conflict minerals in their own computational infrastructures. So, that was one example. I'll give you another. We spent a lot of time digging through patents. Patents are an extraordinary way to, see the imaginaries of tech companies. Obviously, patents in many cases are a type of enclosure of knowledge. You're trying to grab a particular way of producing a system or making a tool before somebody else does. It doesn't necessarily mean that you make all of the things that you patent, but you grab them so that they're now your intellectual property. So it acts as a kind of weird map in itself. You get to see how Google or Amazon or Microsoft are thinking about where they're headed. So at one point, Vladan and I were digging through hundreds and hundreds of patents that Amazon had filed around the time of the Echo and before. And we found one for the Amazon fulfillment warehouses, those giant factories where people do all of the work, the fiddly work that the various robots can't do. And we found one which was for a gigantic cage. It was about 12 foot high that workers would be suspended within so that as they're sort of working on these factory floors with robots that they're not getting bumped into. But these are kind of horrifying cage structures, and we again put it in this particular story so people could see what the cage looked like and think about these kinds of imaginaries of the role of the human body in large-scale systems. See if I can show you the picture. Here it is. So this was a really funny one because when we released it and we put this essay online, we thought it would be read by scholars and researchers and perhaps people who are interested in technology. What we didn't expect is that this story went viral and a journalist got hold of it, and then suddenly sort of 150 newspapers were writing stories about the Amazon cage. And it was one of the rare times that Amazon actually responded to public criticism by saying, we haven't built this cage. We're not doing it. We actually did something else. We have a vest that constricts people's movements as they walk through the factory. I'm like, is that better? I'm not sure. It's kind of the same problem. Okay, thanks. But it was sort of one of those really strange stories that you don't know what people will pick up on. But it took, I don't know, honestly, probably 8 weeks of work just trawling through all of the patents to get that sense of which, essentially we collected 80 patents, which we've also shown in relation to how Amazon imagines its own planetary infrastructure. But yeah, you can see several of those points on the map where basically those stories become nodes. Some of these nodes are actual diagrams. This is diagrams of the largest ISPs around the world. That's a traditional, data visualization. And some are much more speculative, where we are gathering the various risks and hazards of a particular type of infrastructure in the AI supply chain. Okay.
It's always amazing to me, like that the moment that you do something which goes viral and how something turns from just research into action. It's the same thing actually that happened with your ImageNet project, the one that you did with Trevor Paglen, and I love showing that and as an example for our students, because we really do take a critical activist type of approach to what we're doing, and just the fact that you actually managed to edit the classification of the ImageNet system was just such a huge success. So I don't want to go into that project, but maybe let's make a shift to this giant thing, which I hope you're going to orient us in. And I think today a lot of people we think about Gen AI right now as almost the same we might have thought about the internet in 1992. This kind of empty library. The internet was an empty library, and look at it now. It's so dominated by 3 companies. We would have never imagined that it went from somewhere where we could be so free and have such a utopian attitude to the moment that it was today. But I don't know, there's something about Gen AI that gets, Sarah was very beautifully talking about small language models today, but generally we think about Gen AI as this thing that needs to be fed, fed and fed and fed by us, by our data, by our images, by all the things that we have, out there on the internet, which I think, this project over here really counteracts or dispels that idea. So maybe you can just talk a little bit about your definition here of planetary AI. That was your choice of topic for today, and how all those planetary resources and labor and data feed this giant machine and set our expectations from them, from something that simply exacerbates all the existing conditions, right? Of
Right.
those,
No,
those
absolutely.
economies and transfers.
Yeah, I mean, I think this is one of the big things, and I hope we can talk about it further today in the sort of broader discussion after our sort of in conversation. But generative AI, for all of its uses, is part of what is one of the most concentrated industrial systems in the world. We're really talking about 3 companies in the West that can do generative AI at scale in terms of having sort of the full infrastructure. And in China, we're talking about 2. So you really have to go back pretty far to find a more concentrated industry. It's certainly being compared to things like big oil or the railways. But what we've seen, certainly in the last 10 years of artificial intelligence, has actually been a further concentration of the tech sector rather than a larger opening up. And we can talk more about why that's the case. But I think what's really interesting is to look at the fact that this sector is going to be spending around $1 trillion in the next 3 to 5 years just on AI infrastructure. I mean, that is an absolutely staggering amount of money. And you can put it in historical context. We can think of something like the Manhattan Project, which at the time was its own just historic experience of trying to centralize resources for a particular type of technological outcome. If you put that into today's dollars, it's around 40 billion. So, I mean, again, just as a scale difference, we're just looking at something that's truly one of the largest things that we've built as a species. And it is in the hands of a very small number of people who really get to decide what will happen with that infrastructure. So part of the work that I've done since Atlas of AI, which came out in, 2021, so a lot has happened since then, is really moving from what that generation of AI looked like to generative AI and what has happened to that sort of infrastructure story since. And so while I was doing that sort of work, which again involved field work, going to sort of weird places where the hyperscalers are creating this new infrastructure just for generative AI, it was really clear to me that we're getting stuck in this kind of technological presentism where we're so fixated on generative AI in the present moment that we're not looking at the histories of how this has happened before and how it will happen again. Why we're not looking at the multi-century view of the forms of extraction, enclosure, and automation that are being echoed again today in generative AI. So it was almost born, this project, Calculating Empires, was really born out of a frustration with the discourse about generative AI, which is so focused on the thing that just happened, the latest model, the latest technique, and not, okay, how is this built? Why are there only kind of really 3 companies that are able to do this at the moment in the West? What does it mean when you only have 3 companies doing this? And how are they doing it? Like, where is that data coming from? What forms of dispossession are happening with its extraction and its retrieval and its reuse? And what can we learn? So it's COVID. It's like the beginning of COVID. Vladan and I are both grounded on different hemispheres of the Earth, actually. And we were like, look, we've always wanted to do the kind of deep history of AI. Why don't we do it while we can't move? And we have to read a lot of books and a lot of papers and just really kind of go deep. So we started by looking at 100 years and saying, okay, if we start to think about a 100-year history of artificial intelligence, what do you learn? Of course, you go back to sort of the birth of particular mathematical models, you look at the emergence of particular industries, and you look at particular forms of automation. And then we're like, okay, this is great, but it's actually not telling us enough. You need to look back at 200 years. And then it became 3 and 4, and then pretty quickly, we're like, okay, we can start in the 1500s with the emergence of long-haul merchant shipping, and of course, the emergence of capitalism, and indeed, as I can see you're about to say, the printing press. So you start to see these sorts of network technologies emerge in the 1500s, which I think, again, give us different tools to think with about our current moment. So you're seeing this kind of flick through the expanse of what is about a 24-meter map and 3 meters tall. It's very hard to do this as a website, by the way, but it's there and you can zoom in and have a look at it. But what you'll see in this is that we've tried to use a very different lens for thinking about this moment. And I'm very influenced by Ferdinand Braudel, who, as a sort of French historian, thought about time in 3 different ways. He thought about the event. So when something has just happened, he saw this as perhaps one of the least interesting ways of thinking about societal impacts. The next one was the conjuncture, sort of somewhere between 10 and 20 years. He said you can learn some things from looking at a conjuncture, but nothing like if you look at the longue durée, which is a century or multiple centuries. It's like that's when you really start to learn about what's going on when we want to talk about societal change and economic change and cultural change. And so this is very much a longue durée project. And it was, I have to say, deep at a personal level, really refreshing to be thinking in this kind of historical depth rather than constantly being DDoSed by new AI models, which of course in my work I also had to understand and play with. And many of us have just been spending our lives trying to get our heads around these new models. So it would mean that, for the rest of the time I'd be like, well, I'm in the 1750s today. What was going on there and what can we learn about for today? So I sort of got really into sort of specific moments in time. I'm really interested in the age of encyclopedias as another moment that we can really learn from. Let's think about sort of the 1820s to 1850s, this desire to capture all human knowledge into translatable systems that could be easily accessed or to create universal languages. I think we're seeing something very similar with generative AI, this desire to capture all data to create perfect LLMs that can generate any image or any text. And you can see that here. We're just having a look in the algorithm section of the map at sort of the long history of those ways of seeing and thinking. So this project, I hope, is going to be useful to people, not just as an art installation, which is its current life. It's sort of going around the world doing that sort of thing. But hopefully also just here as a website that people can use in teaching contexts, in conversations, to say, okay, what happened with the emergence of the von Neumann architecture? Why did it dominate the way we started to think about information retrieval? How did it change the way we started to think about computation itself? What did we lose when we stopped thinking about biological computation or different forms of knowledge analysis? What happens if we put them together in time and see what sorts of ways of seeing were becoming dominant and what dropped away? That for me has been just incredibly helpful as a way of just not becoming lost in the quest for constant newness that we've experienced in the last 2 years of generative AI.
Yeah, so maybe you can guide us through how you came up with these classifications and topics, and maybe just choose a few that you want to guide us through, because they're obviously highly curated, and I don't know if they came first in terms of directing your research or whether they came after in terms of, sorting through the incredible research you've done.
Yeah, well, I guess the first thing to say is that this map is categorized in 4 big areas. So it starts all the way over here. In fact, we can use this little tool to go all the way to the beginning. It really sort of starts with communication devices. So the sort of history of communication systems and infrastructures. You could think about this really as kind of pretty classic media archaeology. So, really starting with concepts like artificial perspective and the emergence of artificial perspective in the 1400s, how it changed particular ways of seeing and representation, and then sort of moving through all of these tools and networks from telegraphs and telephones and typewriters and television, personal computers, mobile phones, and all the way up to generative AI, as all bringing their own types of lensing, ways of seeing and ways of locating oneself in the world. Then we move from that story across these devices into the next level back. So you could think about a device is an interface that you can see and touch. What sits behind it? Well, what sits behind it is infrastructures. So here, and I'm just going to make sure I'm bringing us to the right section, the interface itself, so that's the bit that you're interfacing with, and then here we have the languages behind it, the infrastructure behind that, And then even further back, what are the tools and systems that allow those interfaces to be constructed? So here we've gone into the story of computation. And I'll show you this as an example of something that is a data visualization here.
Yes.
This is about AI data sets. You've heard a lot about them today in different panels. This looks like a giant shape, which it is, but it's also a data visualization of all of the core data sets that have been released publicly for all of these different types of computer tasks, from vision, game data, graphs, medical data, NLP, for example. So each one of these shapes represents, right at the top, hundreds of thousands of data sets, whereas down here, we're really just looking at handfuls of data sets. In fact, if we go all the way down into the 1980s and 1990s, I can really name them for you, and I've spent time with many of these sort of individual data sets. And then they really start to explode around here in the sort of late 1990s, early 2000s, and you start to see this sort of gigantic shift, particularly in computer vision, but we also have coding data sets, we have audio data sets, it goes on and on. So then basically the map continues to take us through classification mechanisms. So how does classification work as a system of power? So we're really interested in that story throughout this entire project. And then we go into the social forms of control that draw on these systems. Time as a concept of how do we create order and control. Education. How do we think about emotions and intelligence? The human body itself. What are the stories of how the human body has been controlled from the corset to large-scale medical data? And it goes through multiple systems of knowledge, from prisons to borders to how do we think about architecture as a form of control and power. Oh, there's one you want here. Lovely. Bureaucracy.
This one.
Want to talk about? We love bureaucracy.
Yeah. Those lines in the middle there.
Yeah, so this is again a visualization about empire. So it really shows you some of the world's largest empires at their peak. So how much land mass did they control at their sort of height of their power? And we've gone again back to the 1500s. So this looks like a pretty set of lines, but if you zoom all the way in, you can actually say, okay, I want to learn about what happened with the Ottoman Empire, or what happened with the Soviet Empire at its height, and the British Empire, which actually, this still shocks me, controlled 1/5 of the world's population and 24% of its land mass. Yes, I mean, it is kind of shocking. Anyway, so then we move into architecture and spatial organization, which I know many people in this room love these histories, and this was also really fun for us to get into. I think one of the big cores of the map, if I was going to say there's like a heart of the map, is sort of really around here, which is the story of European colonization. It really is a profound story that goes from changing the climate of the planet, changing how people understood themselves, their bodies, and the people around them, to how they understood their ecologies. And we see those patterns of colonization just continue to play out, again now, in the empires of artificial intelligence as well. So it's all here for you to have a look at. We end in military systems. It's been really extraordinary for me to use this map to understand some of the things that have been happening recently. So, for example, we have a section on satellites and the use of satellites as a military technology. Of course, many people are like, yes, but satellites are also a public technology. It's interesting, we make a strong case in the map that, in fact, they've always been military technologies. And in fact, what we've seen with Elon Musk recently is that, indeed, he has become the only person who can put DoD satellites into space, and as of last week, is now doing reconnaissance satellites as well. So again, I hope in some ways this becomes like a useful way to track these stories and almost to see if you can read contemporary events against those histories. Yeah. Did that cover it?
I think
it's
covered.
It takes a long time.
I know, but that's what's right. I mean, that's what's amazing about this image is, well, this map, the system diagram. You become a storyteller with it, and it's an amazing kind of project that all these little pieces are indexes, either for you or for one of us to go deeper into any piece of research about this. And I, just in terms of the visuality and the image capital, that number one, this pulls together, and number two, it critiques, but number 3, it lays out, so it's very concise on the one hand, but I think the website is fantastic because it does allow you, not to segment this system diagram into the various pieces and to be able to jump around it in all kinds of different ways and to understand that part of it is just hand drawn. One of my students actually thought that this is a data visualization, that this whole project is a data visualization. And just the impossibility of even thinking that could even emerge from a single system is so unthinkable, So
It'd be nice, though, if generative AI could do this, or if anyone has a generative AI system that can do this, please let me know at the end, because you will save me years of my life. It would be great to get that time back. But I love that you use the term index, because I think more and more that's sort of how I think about this project in particular. We were really, really, I have to say, pretty jumpy about doing a big history project. Big history projects, as we know, get a bad rap for various reasons. But we've been really, really clear with this project that it is not trying to be a history of everything. It's really trying to do a very specific, subjective intervention. It is making a very strong set of theoretical and historical arguments, but it's also open. So every time we stage this as the sort of 24-meter installation, it's staged with huge books, which are basically allows you to read this, as a book up close. Okay. And we stage it always with pens and pencils so that people can actually write in it. And initially I was like, okay, is anyone actually going to do that? Or, are we going to get I Was Here or the classic Dick and Balls? And indeed we did. Yeah. Many, many Dicks and Balls were gathered over the course of having these books out. But extraordinarily, we got more substantive comments than that, which was perhaps the thing that I was most.
Are the books all organized in the same way, or do they take different trajectories?
The books are organized in the 2 halves: communication and computation, classification and control. Okay. And then we collect the books after every exhibition. There's been 5 exhibitions at this point since when it opened at the end of last year. And we have just hundreds and hundreds of people saying, okay, I want to add this, I want to change that, can you include this, or this happened in my country, I'd love to see it reflected. So every time we stage it, we add to it. So it kind of becomes a never-ending project, which is another reason that if you can generate it, it would save a lot of time. Yeah. Because it's become a kind of a weird maintenance project. But what I love about that is that it isn't trying to be a closed loop. It's trying to be an open, expanding index.
Yeah, well, I hope AI can never make this. That's just my own fear and dream. But how about if we move forward? Like, what are you working on now? Yeah. And just take us a little bit forward, and then we'll open up to questions from the audience.
Sounds great. Yeah. So I'm writing the next book, but separate to that, I've been doing a set of projects thinking about latent space. So latent space, as Mark and others in this room would know, is essentially the sort of compressed space that is where models actually put things in relation to each other. So you heard from the panel earlier about the way in which generative AI systems are really just statistical analysis at scale, where you're making predictions about how often things appear in relation to each other. The way that they do that is by taking these enormous data sets and then compressing them into many, many, many dimensions, in some cases up to 1,000 dimensions. It's very hard for humans to think about sort of 1,000-dimensional space, but that's effectively what is being done with these large-scale neural net models. But in 1,000-dimensional space, things get very, very compressed. So context goes, a whole lot of sort of features of a particular thing are lost, but many other features are seen and in some cases imagined. So I've been working with computer scientists to think about what happens, particularly with images. What happens when you have a very, very large data set, like line 5B, which has 5 billion images? How are they arrayed in latent space? And what happens when you're generating images from latent space? I'm really interested in these questions because as an architecture, latent space has become possibly one of the most important unseen architectures in generative AI. Very few people are actually really trying to generate things from it or to understand how it's organized. So I'm actually working with people at Columbia thinking about some of those questions. So if other people are interested in talking about latent space, please come and find me afterwards. But it's a really hard problem, and it's a really interesting one, because I think the more that we understand about how images and text are being generated in generative AI systems, the more we'll know about this idea that it can do anything, which I think is a very real trap. In fact, they don't produce anything. They produce very specific kinds of things. And it also, part of that is what we feed them with, but part of it is also their architectures, their underlying architectures. So I think that's a really interesting problem.
Yeah, okay. Just one more question,
Yes,
Bruce, because within the latent space, I think nearest neighbor is, it's one of the things that we're doing in our history of algorithms project, and it's such an interesting idea because it takes something that's so non-spatial and turns it into a spatial concept. So are you thinking about that in relation to the latency? And
absolutely.
Yeah.
But tell me more about the nearest neighbor project.
Well, we're just starting to try and understand it in all its different dimensions, the way that it's used in architectural in data visualization and mapping and making presumptions between things that should look similar to each other, but are not when you think about it in terms of space and time connections. But on the other hand, it creates similarities between things which aren't similar because you're putting them together in this multi-dimensional space. So I'm interested in both of those aspects of that algorithm. Yeah.
I completely agree. And I think one of the things that I also find really interesting is putting those architectures together with the training data sets. And really, for years, certainly prior to ImageNet Roulette, I mean, what sort of produced ImageNet Roulette was spending a lot of time with ImageNet, which seems quaint now. It was only 14 million images, back in 2015
Crazy.
when we were working with it. But
Yeah.
the new one that we've been working with Line 5B, it really helps me to understand that these are not representative samples of the internet. I mean, we talk about internet scaled training data, but it is not, everything online put into a giant file. It's very, very specifically targeted towards harvesting images from particular sources. So in a study with Knowing Machines, which is sort of my research group, and this was led by Christo Buschek, who is an amazing data thinker and data visualizer and data investigator. He got the Pulitzer for his work looking at Uyghur training camps. He and I were looking at Line 5B, and he noticed something really interesting, which is that the largest site from which Line 5B harvests its images is actually an e-commerce site called Shopify, not Spotify, the other one. Yeah, Shopify. So why would you choose Shopify? Well, of course, because everything there is a labeled image for sale. So it's really, really easy to get cheaply labeled images. But when you're labeling things for an e-commerce site, you're labeling to try and sell them in a very particular way. So what that means is that those captions that go with those images are really there to try and sell you something. So it's like when you train on this data, you're seeing like a shopping cart. It's really very specifically looking through the goggles of e-commerce. So what does that change in terms of the images that you're generating and the kinds of understandings of the world that have been compressed in latent space? So there's so much to talk about there, but it is really fascinating because it is so little.
What a great new project.
Yeah.
Okay. Well, I'm looking forward to the next diagram. Okay, but since there's only one person here, we're going to open it up to the audience in Q&A by raising your hand, although we have collected all the questions. So Adam, as you peruse the questions, by the way, today, if all the panelists are here, we're going to email you all the questions that were asked. It was actually an amazing level of participation. And this is Hal, who designed the, yes, really great. Hal Lee. So questions. And Adam, if there are really burning great questions. Yeah, questions from the audience? Yes.
One here.
Okay.
Hi.
Yeah, we have an actual mic now. Yeah, that kind of system.
Actual mic.
Yes.
Hi, first of all, thank you to everybody for the incredible day, really incredible. So I have a question that is really general, and I believe it's not a new question, but I'd like to know the point of view from both of you. Because behind AI there is also a big ethical question. There is, we are teaching AI to be intelligent. Who's teaching AI to be just? The corporations who make profit, the politics, who in some places are form of profit, and in other places they don't interfere with the free market. I know some governments like Europe is more, the European Union is more attentive on this issue, others are less. I'd like to know, your opinion on who's the guarantor? First, I want to say just one thing. This is like a backstage story. I know just one person from a long time who works in AI. He started working 24 about years ago, first for Yahoo and then for Google. He's not a programmer, he's not an engineer. He has a master's degree in philosophy and a PhD in philosophy. This is interesting.
Fantastic.
Thank you.
Yeah, I mean, you know, you're pointing to something which I think is the driving force behind the work that I do, which is to really ask those questions around how power is distributed or not distributed, and what motivations are driving the construction of large-scale AI. Because we so frequently talk about AI systems without looking at the political economies in which they are very clearly based and what they are driven by, which is almost entirely by for-profit companies whose primary responsibility is, of course, to their shareholders, not to the wider public. And we had one weird exception to that, which was OpenAI, very, very briefly, as a full nonprofit. And we all saw what happened there. And they're now very, very quickly moving towards a full for-profit structure. And there's a lot of really interesting stories around why that is the case. But I think you can also see a relationship which is really important to make clear today, which is the infrastructures of AI are so extraordinarily expensive and so environmentally intensive in ways that I'd love to talk more if you want to hear more about that. It's something that, again, I've been focusing on a lot, that it's extremely difficult to do that if you are not a for-profit company, because you have to have just extraordinary access to resources. So you could imagine something like a nation state saying, how would we create a full public system? Or even more radically, you could imagine a nation state nationalizing a currently private infrastructure to say, well, this should be for the public. How do we actually bring that conversation back around what is it to nationalize an AI infrastructure? That is a really exciting conversation to have. But even if we get past that question, which is the political economy and the ownership, we have to ask the environmental question, which is every time you use generative AI, it's using around 15 times the amount of energy as a traditional web search. Every time you have an exchange with something like ChatGPT, it is the equivalent of pouring a half-liter bottle of fresh water onto the ground. And we already know that generative AI is using as much power as the entirety of Japan with a similar carbon footprint. So, and that's just now. And of course, the International Energy Agency has said that that's going to be increasing dramatically, possibly to about 8% of the world's entire energy budget within 5 years. That is extraordinary. Like, we can reel these numbers off. We've all heard them now. I've been lucky enough to be parts of the research teams with people like the amazing Emma Strubel and Sasha Lucione, where we've been studying these sort of energy and water impacts. But the more we look at them, the more horrified we are. Like, I am not feeling weirdly inured to this. I'm not over it. I'm actually continually more concerned that this is not the number one topic of conversation when we talk about using AI. Just last week, Google said that they're going to bring 7 nuclear reactors online in the US alone just to power generative AI. And so we need to have a conversation about that as an energy system, about the legacies of nuclear. Seeing 3 Mile Island powered back on is a bit of a shock for many of us. So I think these are the contexts where we have to begin to have these conversations. These tools are exciting, but by using them, and I also, you know, like many others today, can see really interesting uses, but we have to offset that with an understanding of the very real material costs that come along with them, which means that we need to be designing them differently. We need to be thinking about them differently, which is don't just stick an LLM onto everything for the lols, but actually think really carefully about if it's needed, and then change the way they're being engineered from the ground up. So they're the big questions that I would say that are facing us when we think about power and AI.
Any other questions? Yeah, Andres. Yeah, Andres and then Dan. Okay.
Well, very impressive, and happy also that the two of you are together in conversation. It's such a, I think, event for everyone that have been following both your work and admire you, as I do. I have a question because, I mean, I'm not sure, but my feeling is that this genealogy of technology and power since the 1500s, it's not necessarily including these forms of techno-dissidence or even accidents or failures, and I'm curious what that means, if that's a sort of a thesis, because we could read, and actually that's something that comes through, that somehow we might be heading to a point of absolute power, techno-power. And so my question is really about, is there a hope for dissidents and this coordination and alternative within the technological context that we're somehow heading to? And the second question is coordination, which is kind of a second version of the same question. I wonder if the level of complexity that AI has allows for coordination, for sort of a direction or a government of it, or it's also providing a context of, let's say, messiness or.
I love these questions. Incredibly rich, thank you. And I just want to talk a little bit about this. Start with dissidence and start with failures, because failures are a really important part of this map. What you'll see again and again, if you get a chance to read it, is basically in these sort of technological histories, there are many, many nodes that never develop. There are technologies that are released with an enormous amount of excitement and huzzah that actually just completely fizzle away. Then there are some technologies that are developed that open up a set of possibilities and options that are really exciting for somewhere between, say, 20 to 50 years, and then become closed proprietary architectures. So you see this echoing of an opening and a closing happening time and time again throughout this kind of media archaeology side of the map. Laura mentioned earlier the internet. The internet is a really, I mean, you can see it historically, that there is this period of time, really sort of 25 years, of opening up, from ARPANET and onward, whole different ways of networking, of sharing information, a lot of excitement, a lot of new systems and tools being developed. And then you start to see this sort of recapturing and the closing and sort of the shifting to a proprietary set of models and a much tighter control over those networks. So that movement, I think, is really essential to thinking about these stories, and failure is often in them. So there's a lot of stories of attempts to create completely open systems that then I think fail because they become enclosed, again, by corporate structures, by land structures, by other sort of forms of ownership. So you've hit on something really important, which I think is really core to what we saw here, and we saw many patterns, but that's a really important one. But what this map doesn't show you is the story of resistance. So it is not a story of people who have tried to oppose, say, GPS, like the people who would go and literally blow up GPS stations, or the stories of the Luddites. That's because I think in many ways this is a story about power, and we wanted to show those systems of power and how they work over time in order to see how they're still present in many of the things that we use today. What worries me about putting those side by side with stories of resistance is that it's too easy to say, oh, we'll always have resistance, we'll always succeed, there'll always be overthrows. I think it's too facile with these kinds of histories. I think there should be a resistance map, which should be a separate set of tools and systems. In fact, I know groups of activists working on those kinds of maps. There are many over time. But what we couldn't find was a good map of these systems of technology power and technology as power, which is really what this is trying to do. So your second question, which is about coordination, and let me just check, you mean coordination in terms of a regulatory coordination at the level of?
I meant basically the capacity for this to be directed or governed, even and concentrating power, actually, or it's sort of getting to a point that it's an ecology in itself that is domain in,
It's
but not
impossible to
necessarily for a
intervene in.
purpose or for a concentration of power on certain actors.
Lovely. You had a point, Laura? You wanted to respond?
No, just saying that it's impossible to intervene in.
Oh, absolutely.
Yeah, right.
Well, I mean, again, takes us back to the opening and the closing. So, if there's a particular way of reading what's happening right now with AI and to say, look, there's all of these startups, all of these people making tools all of the time, we're seeing a proliferation. Is this not actually, a type of exploration, a complex ecology is emerging? But if you take a step further back, again, as we do in this map, and you look at the infrastructure, who owns the backbone on which all of these systems are being built? Who owns the frontier models onto which all of the small language models are being bolted onto? And you start to see actually a shift from hundreds of thousands of players to 5 to 3. I mean, it very quickly becomes a very concentrated map of power when it comes to those actual systems. And in terms of who can really do planetary scale AI, it is just so expensive now that you're just talking about a vanishingly small number of companies that can do this. And I think it's well beyond actually the vast majority of nation states. It's just simply too much money. So that inherently takes us towards a state which is very concentrated and coordinated amongst a small set of players. If not a monopsony, then at the very least very close to a set of powers who are really thinking about, while competing with each other, how do they maintain a system that allows their mode of AI production to continue. And you can see this playing out right now in I think it's now 25 court cases, particularly in the US, looking at the use of training data. This idea that you can take all data and train a model and call it fair use. We could question that model, but you'll have all of that set of tech companies who own those models running the same argument, that it's absolutely business as usual, and that the internet is, as it was called, I think, by someone at Microsoft or Google, freeware, which I think is, again, deeply problematic. But that is what owning the means of AI production looks like today. It means being able to collect all of that data. So I think, the answer to your question, unfortunately, is exactly as you thought. It's that concentration is actually getting stronger, not weaker.
Okay. One more question, and then I think we'll call it a day.
Thank you. Thanks for this. This is really interesting. My question is actually pretty much a continuation, actually. I was going to ask you to do some inference, which is to say, like, having kind of done this huge project and understanding, I'm curious to know how you see the trajectory of power changing specifically, because AI is a technology that will then alter the kind of landscape of its power. And you also mentioned that $1 trillion, which is an incredible amount of money, and I'm thinking about like the various different incentives people must have, or different actors must have, or that you might have research actors, that the different motivations that you might have researched, which might include geopolitical power, economic power, but also the various different groups believing in AGI or whatnot. And I'm kind of curious, as you see like 2025 onwards, like how do you see the landscape shaping and changing as a result, based off of the different motivations of these actors? Is it at a planetary scale? Is it like kind of a consolidation into a single actor? Like whatever pessimism, optimism aside, I'm just curious, like, having done this, where do you see this kind of the whole graph morphing and changing?
Lovely. And I love that we're forming a bit of a discussion now rather than individual questions. This is what always happens here. This is what you create, Laura. I love it.
It's an amazing place.
It's fantastic. So let's take this idea of the $1 trillion in 3 to 5 years. It is absolutely phenomenal. But you're now starting to see groups like Goldman Sachs say, is this actually a massive overinvestment for not enough return? So that's really interesting. And of course, we saw Darren Acemoglu at MIT, who just recently got the Nobel Prize for Economics, say that we're getting less than like a 0.5% increase in productivity per year because of generative AI. So that's tiny compared to a relative growth in GDP of 2 to 3% every year. So it's really kind of, there's a lot of questions about whether this investment is paying off in economic terms. I happen to think those terms tend to be too narrow, but it is telling you something else, which is that could this also be a failure in itself? We're talking about failures. Could, in fact, generative AI itself be something that could start to really become a fad that we start to say, hey, we don't really need a chatbot hallucinating, 21% of the time to try and solve a problem. However, what I would also say is that because of the amount of money that has been invested in these infrastructures, they're not going to go away anytime soon. So even if generative AI, as we currently talk about it, as LLMs, I think they're really cresting. I think they've peaked. I think we're going to start to see a shift towards very different architectures for AI than this LLM kind of, dominance that we've had for the last 3 years. But you're going to see that infrastructure stick around. So that's why the story is less the story of like the LLM, and it's more the story of this background infrastructure and the hyperscaling, which has been happening. I mean, it really is, I just can't even tell you when you go and you see what has been built just in the last 2.5 years. It is staggering. The scale of these data centers, the amount of chips, the supply chains behind them to make that possible, it really is. My personal bet is that we've just never done anything like it as a species. And so that isn't going away, and it will be repurposed and repurposed. So what I think is going to happen, and this is just a guess at this point, is that we're going to see an increase in speed, because certainly there are areas in which these tools are going to help create a lot of action and change very quickly. And one of those spaces that we kind of hypothesize a little bit in the map is what's happening with quantum. So let's see if we can take us to quantum. Maybe Laurie can help me because I'm over here and my glasses are going to see if we can get us to quantum. Over here,
Yeah, maybe in topics.
Unconventional computing.
Yeah,
Here we go.
control.
I'm going to here and computing. There we go.
There we go.
Here we go. So quantum. So, things here are getting really interesting. I'm sure some of you have been following the story of synthetic organoids. So the idea that, you can create computational networks from essentially brain cells, human brain cells, and turn those into systems of computation. We have that sort of detailed and the history of that here on the map. That's really fascinating because that's a form of architecture which is biological, it's organic, and it doesn't use very much energy at all. However, it raises all sorts of other ethical questions about how we're going to be using the brain cells of the recently deceased, or perhaps of stem cells, to build these new forms of computational architectures. That is all increasing much more rapidly because of AI. Same goes with quantum. I think you're going to start to see quantum taken much more seriously. We're still, I would say, probably 20 years. In my old thinking, I would have said 30, 40, maybe 20 now, from this becoming something that's real. And I think that opens up philosophical questions as well as engineering questions in terms of how we're going to understand the world. If we understand things in a sort of quantum sense, this opens up new possibilities, I think, that are fascinating, but it also opens up a huge national security and international security set of questions, which really drive as soon as somebody really has quantum scale encryption, then every single banking system, every military system is absolutely open for the taking. So that's going to be one of the huge points of focus for the next, I'd say, 10 to 15 years. So I do think we're on the brink of something which is going to look very much like a kind of a scaling law experience of just rapid change very quickly to, in some way, a lot of us, but in other ways, there's going to be real unevennesses depending your experience of inequality, because we're going to start to see that inequality just really get so much more extreme, particularly with climate, increased climate crisis effects. So that's about as far as I like to go thinking about into the future. I'm not a forecaster. I'm very much a researcher. I tend to sort of, look on the ground to see what I can study empirically. But what I am seeing empirically in those labs where they're working on these systems around biological and quantum computing looks like it's going to change really quickly. Thanks for the question.
Okay. All right, so maybe we can end, and I know also you're in the conversation, but I know you're also doing some work with Marina Otero, who's also a colleague of ours over here at GSAPP, and
She's great.
her idea of data mourning, I think, is very topical in terms of what you're talking about right now. And also to say, I'm still recovering from a talk that Hod Lipson gave to my computational design practices students. And there was a moment in his lecture where he talked about how artificial, these image recognition systems could not tell the difference between a dog and a cat for years and years and years and years and years. And it was only at this moment, right, David, where you recognize the difference between a dog and a cat that all of this emerged. So I don't know. I worry about the fact that that was the question, that the difference was between a dog and a cat. And we keep coming back to that, you know, on the internet you could
That's why
be
we
a
have to end on
dog.
the cat.
There we go. That's why.
Both alive and dead.
That's what got me going on that one. Okay. All right. Thanks
Thank
so
you
much,
so much,
Kate.
Laura.
Yeah.
It's been a pleasure.